Hey guys, welcome to Pre-Calc, Lesson 7.1, Arithmetic and Geometric Sequences. All right, first let's talk about the definition of a sequence. It's simply a one-to-one correspondence or function between an ordered set of numbers and the integers from 1 to n. So, for example, what we have is a term, otherwise known as the index, and then the value, or number. All right, so the term is equal to n, and the value or the number is a sub n. So if I create correspondence here, 2, 3, 4, 5, ... that would be the term. The first term, second term, third term, so on and so forth. So these always represent your counting numbers. Start with 1 and go up by 1 each time. The value can be anything. It just depends on what the pattern is. Well, let's talk about the odd numbers. 1, 3, 5, 7, 9, so on and so forth. So if I want to pick one of these at random right here, what this is saying, all right, I'll actually circle that, is that a sub 3 equals 5. Okay, so that's kind of how that works. First example, give the first 5 terms of the sequence a sub n equals 7n plus 3. Now, you're going to be able to do this a lot quicker, but for the sake of notes, I want to take some time here to explain how we get this, especially when these become a lot more complicated than just 7n plus 3. So if I want to calculate a sub 1, all I need to do is take this 1 and plug it in for n in this expression and multiply and add all this stuff out. Okay, so this becomes 7 times 1 plus 3, which is obviously 10. So there's a sub 1. To get a sub 2, I take 7 times 2 plus 3. That's 14 plus 3, that's 17. A sub 3 would be 7 times 3 plus 3. So 21 plus 3, that's 24. So you can kind of see what's happening here. In addition to just plugging in for n, a pattern is developing over here. How'd you go from 10 to 17? Well, I added 7. How'd you go from 17 to 24? Well, I added 7. So you can kind of predict what you need to do for the next 2 terms. So you can kind of come at them from the back end here. 24 plus 7, well, that's 31. 31 plus 7, well, that's 38. Well, let's see if that fits. A sub 4 is 7 times 4 plus 3. That's 28 plus 3. Yep, that worked. A sub 5 is 7 times 5 plus 3. So that's 35 plus 3. Yeah, 38. So there's a couple ways you can get that. You can establish the pattern first, see what that is, and then use that shortcut to get the other ones. All right, well, what happens now if they give us the sequence? All right, and I want to find the 12th term. Well, I'm going to do one example here and kind of hopefully illustrate why you're not going to use this method for the rest of the unit, especially when I need you to find like the 100th term or the 200th term. So I've got a term and I've got the value or the number. We're just going to do a chart here. Plug and chug. So the number I have is 8, 11, 14, 17, and 20. So now this represents the first, the second, the third, the fourth, the fifth. I need the 6th, 7th, 8th, 9th, 10th, 11th, and finally 12th. Well, what's going on here in this pattern? Well, 8 to 11, what did I do? I added 3, added 3, added 3. So what I can do now is just continue this by adding 3 every time. So this would be 23, and then that plus 3 is 26, plus 3 is 29, plus 3 is 32, plus 3 is 35, plus 3 is 38, plus 3 is 41. So find the 12th term. Here it is, 41. I don't want to do that every time. All right, so what we're going to do is we're going to come up with what we call an explicit definition or an nth term rule. I want to find a pattern. How does this work? Well, take a look here. A sub 1 equals 8, a sub 2 equals 11, a sub 3 is 14, so on and so forth. A sub 12 is 41. What's really happening? Well, to get 8, if I also have to include the term number somehow, how do you get a 1, go from there to an 8? How do you go from a 2 to an 11? How do you go from a 3 to a 14? Well, what I'm going to do here is think about this as 8 plus 0 times 3. This is 8 plus 1 times 3. 8 plus 2 times 3. So on and so forth. This is actually 8 plus 11 times 3. So how do these relate? that 1, that's a 0, that's a 2, that's a 1, that's a 3, that's a 2. This goes up 3 every time. There's a 3 every time. And this is 8, and that is 8. And all of these start with 8. So a rule could be something like this. A sub n equals 8. Because if you notice, all of these start with an 8. Plus, because I'm adding for all of these, this is 3 in every instance. 3 is what we call the common difference, what we go up by each time. So that's 3 times n minus 1, right? Because if you notice, this number here is 1 less than that every time. So this is what we would call an explicit rule or an nth term rule. It's actually kind of easy to derive. So an arithmetic sequence is simply a sequence of numbers with a common difference. And that common difference is denoted with a D. And this is a very, very important formula for us to use. Now, where do those numbers come from? Pretty straightforward here. A sub 1 is simply the first term in the sequence. D is called the common difference. And then obviously n minus 1, this number here is 1 less than your index number. Okay, so give the first 5 terms of the arithmetic sequence. So for all of these, you know it's arithmetic. So it's increasing or decreasing, if D is negative, by the same number every time. So there's a couple ways you can do this. What I generally like to do is start off by just plugging into my explicit rule. So a sub 1 is 7 times 1 minus 12. 7 minus 12 is a negative 5. A sub 2 is 7 times 2 minus 12. All right, so what's that? 14 minus 12, that's 2. So what I notice now, because it already tells me it's arithmetic, I don't need to go any further, because it looks like I just went up 7. So if you want to find a sub 3, a sub 4, and a sub 5, I could just take my previous number here and add 7 to it. Okay, well, I think that might be a little bit quicker. So 2 plus 7 is 9. 9 plus 7 is 16. 16 plus 7 is 23. So there you go. You found the first 5 terms. Okay, so this one right here, a sub n equals negative 3n plus 22. So same thing. I want to start by plugging in, find a sub 1. What's negative 3 times 1 plus 22? So negative 3 plus 22, what's that, 19? A sub 2 is negative 3 times 2 plus 22. All right, so that's negative 6 plus 22. What's that, 16? So what's happening here? What's happening here is you're decreasing by 3 every time. So now if you want to apply a shortcut to find a sub 3, a sub 4, and a sub 5, I take 16 minus 3. Well, that's 13. 13 minus 3 is 10. 10 minus 3 is 7. So in this arithmetic sequence, it's actually decreasing because D is negative. All right, and the last one here, they don't give us a rule. They tell us what the first term is, and they tell you what to increase by every time, 3.5. So here I know a sub 1 equals 43. A sub 2 is simply going to be 43 plus 3.5. I'm not going to write this out every time. I'm just showing you where I get it. So that's 46.5. A sub 3 would be 46.5 plus 3.5, which I believe is 50. A sub 4 would be 50 plus 3.5, or 53.5. And a sub 5 is 53.5 plus 3.5, which is 57. All right, next, determine if the sequence is arithmetic. If so, find the explicit definition. So basically what you need to do is determine, do I add or subtract the same number every time? You have to test it for every number in the sequence. They're not going to give you a lot, but you have to test it. So 17 plus what is 23? That's a 6. 23 plus what's 29? That's a 6. You just have to make sure it works here as well. 29 plus 6 is 35. So yes, indeed, it's arithmetic. So now, to find this explicit definition, a sub n equals a sub 1 plus d times n minus 1. That is a very, very important formula that you have to have memorized. We're going to be using it a ton this unit. So what do we know? A sub 1 is 17. D is 6. So to write my a sub n rule, it would look like this. A sub n equals a sub 1, 17, plus d, which is 6, times n minus 1. Now I would just leave it like that, but another option, what you could do is you could clean this up. You could distribute that 6, and you get something that looks like this. A sub n equals 17 plus 6n minus 6, and then combine some like terms, so you get 6n plus 11. That would also be an acceptable answer. And in some instances, this is going to be better to use, and in some cases, this will be better to use. So if you just have to come up with an a sub n rule, I generally leave it like this. But if I need to apply that in a summation, which you don't really know what that is right now, but you will in a few days, then I like to clean that up, so I think that's easier to work with. But it's good to know both. All right, next example. Let's see, 8 plus 3 is 11, 11 plus 5. So right away, I don't even have to go any further, not arithmetic, because you're not adding the same number each time. Okay, that's arithmetic in a nutshell. Let's talk about geometric. Geometric is a sequence of numbers with a common ratio, and that's denoted with an R. So basically what that means is you're either multiplying or dividing by the same number. We don't really like to consider division, so you're either multiplying by a number greater than 1 or multiplying by a number less than 1 if it's division. For example, if you're dividing by 2, you're really multiplying by 1/2. So the rule for this is a sub n equals a sub 1 times r to the n minus 1 power. And again, this is a super important formula. This is a geometric sequence a sub n formula we need to have memorized. Okay, give the first 5 terms of the geometric sequence. So I'll approach this kind of like I approach the arithmetic. I like to plug in a number for 1 and 2. So this will be 4 times 3 to the 1 minus 1. Well, that's 4 times 3 to the 0. Remember, anything to the 0 power is equal to 1. So that's just equal to 4. A sub 2. 4 times 3 to the first. Right? I'm not going to bother writing it 2 minus 1. Well, 4 times 3, that's 12. Since they told me it's geometric, right now I can take a look and say, oh, I'm multiplying by 3. So to find my other terms, I just have to keep multiplying by 3. So I can do that without plugging in anymore. A sub 3 is 12 times 3. 12 times 3, 36. A sub 4 is 36 times 3. 36 times 3 is 108. And a sub 5 is 108 times 3, which is 324. Okay, so there are the first 5 terms for that. Next one, it doesn't give us the rule. It tells us what the first term is, so we're starting at 5, and r is our common ratio. It's 2, so basically that just means multiply by 2 each time. This one's really simple. A sub 1 is 5. A sub 2 is 5 times 2, or 10. A sub 3 is 10 times 2, or 20. A sub 4 is 20 times 2, which is 40, and a sub 5 is 40 times 2, which is 80. So that one goes kind of quickly. All right, next it says find the explicit definition for the geometric sequence. So it tells us it's a geometric sequence. Basically, I like to do a couple things. I always identify a sub 1. All right, so in this case, a sub 1 is 2, and then I like to determine what r is. Now, sometimes this is going to be very easy. Like example A here, it's super easy, right? Look at, we're just multiplying by 4 each time. But these could be fractions. These could contain variables. It gets way more complicated than this. So just a simple concept for you guys to be aware of. When you have to find r, you can always find r by taking a sub 2 and dividing it by a sub 1. Like I said, in this case, it's very easy. You don't need to do that. And it works with any consecutive terms, actually. You could take the 7th term divided by the 6th term, or the 21st term divided by the 20th term. But that's just a very simple way to always come up with r if you can't do it in your head really quick. Okay, so my a sub n rule for this will be a sub 1, which is 2, times r, which is 4, to the n minus 1. All right, next example. A sub 1 is 40. Now, what are we doing each time? Well, you're decreasing in value. So don't think of it as division. It's multiplication, but what are you doing? You're multiplying by 1/2. So r is 1/2. Your a sub n rule will be a sub 1, which is 40, times 1/2 to the n minus 1. And then we could use this. I'm not going to take time to do it in this particular example. We'll be doing a lot of this in the upcoming days. But we can now use this information to find like the 100th term if I wanted to. All right, very quickly. I wouldn't have to take this sequence and list out 100 terms. Likewise down here, if I wanted to find the, 250th term, I could do that in a matter of seconds with a calculator. Whereas if I were just trying to multiply all this stuff out, it would take forever. Okay, last page here. A couple quick examples on how do we find D, which is the common difference. So now I'm talking about an arithmetic sequence, if I do not give you consecutive terms. So if you notice in this particular example, I tell you what a sub 3 is. That's 5. And I tell you what a sub 9 is. That's 41. I don't know a sub 2. I don't know a sub 1. And I don't know anything in between. But I'm going to write those out here. I'm going to derive this formula. All right, so what's happening here every time? To go from a sub 3 to a sub 4, I have to add D. So I have to do that a number of times. And I would just keep doing that until I got down to a sub 9. Well, take a look at this. What am I saying here? To go from this term to this, what am I doing? 5 plus D plus D plus D plus D plus D plus D equals 41. 5 plus 6D equals 41. And now I need to solve for D. Okay, well, I'll subtract 5. So 6D equals 41 minus 5. Now divide by 6. So D equals 41 minus 5 divided by 6. Well, that's the same thing as 41 minus 5 divided by 9 minus 3. So what's the point of me doing that? It's to show you where did we get these numbers so I can create an equation to find D. Well, look at 41 minus 5 is this minus that. 9 minus 3 is that minus that. So my formula, if you will, to find D is going to be a sub n minus a sub m over n minus m. That's basically what I'm getting from that. So in this particular case, if you want to calculate that, 41 minus 5 is 36, 9 minus 3 is 6. D in this case is going to be 6. If you wanted to go further and find an a sub n rule, you need a sub 1. But if D is 6 and you want to go backwards, you would actually subtract 6. That'd be negative 1. Subtract 6 again. That'd be negative 7. So look at this. I could go even further and find an a sub n rule. A sub n equals a sub 1, which we just got to be negative 7, plus D, which is 6, times n minus 1. So this is something you'll need to be able to do. I will give you 2 non-consecutive terms in an arithmetic sequence, and you have to come up with this rule, and then maybe like find the 100th term or something to that effect. Okay, and lastly, let's do the same thing here for R. A sub 3 is 4. I don't know what a sub 4 is, or a sub 5, or a sub 6. I do know a sub 7 is 324. And then I don't know a sub 2 or a sub 1. So again, let's play this game. To go from here to here, I have to multiply by R, multiply by R, multiply by R, and multiply by R. So what would I get here? 4 times R times R times R times R is 4R to the 4th. Well, let's solve that equation. 4R to the 4th equals 324. So what would I do next? Divide by 4. R to the 4th equals 324 divided by 4. Then how do I solve when I'm taking something to the 4th? Well, I take the 4th root of it. Okay? So next I'll take the 4th root. So R equals the 4th root of 324 over 4. And let's examine where these numbers come from. 4 is 7 minus 3. That root, 324 over 4. So check it out. 7 minus 3. Well, that comes from your index numbers. 324 divided by 4, that comes from here. So my rule for finding r is simply going to be n minus m root of a sub n divided by a sub m. Okay, so again, I could do a couple things here. I could actually go ahead and calculate that. This will be calculator active. This ends up being the fourth root of 81, and you should know that without a calculator actually, but that's 3. So now if I wanted to go backwards, I would have to divide by 3, so this would be 4/3, or multiply by 1/3, and then take that and multiply by 1/3, so that's going to be 4/9. So if I needed an a sub n rule, a sub n equals 4/9 times r, which we said was 3, to the n minus 1 power. So that's basically, again, how we would go about finding the 100th term or the 200th term or a sum of a number of terms, which we'll have to do later on, if I give you non-consecutive terms in a geometric sequence. All right, guys, thanks for watching. That concludes day 1. Please reach out if you have any questions whatsoever, and we'll see you in class soon.